All right, so the next section that we're going to go ahead and talk about here is branching and iteration. Okay, so we really only use Python as just a calculator, and computers are good at that, but what computers are really, really good at is doing lots of simple calculations over and over and over and over again. Now, branching. So, control flow and branching. This is where a lot of the real art/design in coming up with algorithms, with recipes for doing things, with adding behaviors is figuring out when a program should make a decision. So I sort of like to think about control flow as teaching a program to actually do things, teaching a program to make decisions on its own. When should that program do something, and what should it do? Okay. So we really have two, three really simple concepts here to do pretty much everything we need to do with control flow and branching. So the first thing we have is we have three keywords. We have the if keyword, we have the else keyword, and we have the elif keyword. So how this works is you have if condition, and that's some expression that returns a Boolean value, a yes or no. And then we follow this by a colon, by a colon here. Then we do an indentation block. So it's one block or a tab indented. And then if this condition evaluates to true, then every expression in this sequence here will be evaluated line by line by line. Okay? So if we want to make a decision and then do something if that evaluates to true, and then do something if otherwise if that evaluates to false, then we do an if else. So same thing, if that condition evaluates true, we evaluate some expressions, otherwise we evaluate something else. And then if we have a sequence of conditions, we can do if condition, do stuff, else if or LIF, something else, do something else, ... And then finally an else, do something of the else. So I will do a couple little examples here. So I do if, so I do if space 1 equals 1. Then I put a semicolon here, and then I pressed enter. So now the editor here is smart enough to know that the following thing is going to be a block. So remember, a block, it's a sequence of expressions that are all, a sequence of lines that are all evaluated one after the other after the other. So if I press enter there, it's smart enough to give you a little indent there. So you can do print, yes, 1 is feed. And then shift enter, then obviously, that evaluates to true. Well, then I can experiment. I can play around with this expression. I can go up 2, okay. Yeah, I press shift enter. you see how it cleared out the previous result and then gave me back nothing, because that's obviously not true. Okay. So if I go up here, I can either up arrow with my cursor, or I can use the mouse to go there. 1 equals 1. Else. Okay. Nope. Okay. So you see how I'm formatting these things of, if you go to the end and if you do a semicolon, you press enter, it automatically indents you. But if you keep doing a new line, A, Z equals 1, B equals Z 1, blah, blah. If I keep adding more expressions here, the editor will automatically put me at this indentation level. Okay? So now when I'm done with this block, I need to decrease my indent back 4 spaces or one tab. I need to, okay. So let me do that again for you. So I type some commands, then I pressed enter. Okay, I pressed enter, and then now the next statement, it wants me to be in that indentation block. So I press the left arrow on the keyboard, and that brings me back to the beginning of the same indentation level as my if statement. Else, semicolon, enter, automatically indents you. Print. Nope. No, shit that. Yup, it's indeed equal. I can play around with this. Go up an arrow. Go up 1. Change that to 2. Yeah, okay. So as we'd expect. Okay, so it's the keyword, expression, semicolon, indent block, decrease my indent block when I'm done with that, and when I want to continue normal control flow. So let's do something actually useful. Okay. So we'll come up with, let's just go ahead and make 2 numbers here. Be a little next exercise here. We'll just say x equals 1, y equals 3. Okay. If x, oops, x, yes, up, nope, go back up there, okay, so forth. Okay. So let's make this a little bit more complex. We can go back up here, we can change that to, so if 2 numbers are equal, well, then they're equal. But if they're not, then one has to be greater than the other. So let's check that. Elif x is greater than y. X. You know what? Let's do this. Print x is A little fancier prints there. Else. And then go back here, decrease the indent, tab to give me an indent block, print Y. Okay. So if I run this, I can right away see that I'm going to get an error here. Who can spot the little syntax error? Who has some good eyes to see where I made a syntax error? Yes, exactly. I forgot the comma there, okay? So I'm going to go ahead and run this with my syntax error. Oh, no, I made a syntax error. Comma. There we go. Yep, very cool. One. Yeah, okay. Okay. So, syntax errors. I'm going to give you a little example of what happens if you do a logic or a semantic error. Why? Ah, hey, that ran. It did not give me an error. It's completely and totally legally valid code that gives me the wrong results. Okay. And when you see things like this, when you see the wrong result, I mean, you have to go back and figure out, hey, I probably made a mistake somewhere. And really, the only way to find these is just by practice and getting some intuition as to what your program is actually supposed to do. Okay, so those are little introduction to the basic kinds of conditionals and the indent block. So, hold on. So I already covered this a little bit. So what happens? What happens if I make a mistake? What happens if I accidentally mix up my equals with a single equals? Any guesses? Is this valid? Let's see a guess. Yeah, it's a syntax error. Okay, yeah. Yeah, it's a syntax error. Now, Python is nice enough syntactically to say, yes, you legally cannot do an assignment when you're wanting to do conditional. Many other languages will allow you to do that, which is a real source of error. But this is one of the nice areas where Python gives you a little bit of extra checking to help catch you when we all inevitably make mistakes. Okay. So let's do an exercise here. Let's enter two numbers here. And then, I'll go ahead. I will start this for you. We got X else let's do two numbers, and then yes, we have. I'm going to give you a little skeleton here, and I'll leave the actual exercise up to you. So x. Okay. So your task for this exercise is to figure out what to put there. Actually, if actually a little more complicated than that. Okay. Yes, yes, yes. So remember, my let's see who got the right answer. So it looks like yes, yes, yes. We use the modulo operator, right? So we check if remember we do 3%, 3, at 0, 3%, 4, 2, 3. Yeah. Okay. Yeah. So we use a modulo operator there. So we can go back up here and we do if x percent y equals 0. This technically will work because the modulo has a higher precedence, but because modulo it can be a little confusing, I strongly recommend putting parenthesis around modulo or any uh, modulo, exponentiation, things that there could even be the remotest question. I strongly recommend putting a parenthesis around it, just to be clear. It's important to be clear. Okay. Okay, good. So we can do 1, 7, 1. Yes, 7 is divisible by 1, 2. Okay. So that's a first little example of how to do if it's if one number is divisible by another. Okay. So, okay, is everybody good? Yeah, yeah, we can even, yeah, so we can check if the even, yeah. So let's go ahead and extend this out to, yeah, so we can do if x divisible by 2, x even, Great. Okay, good. So we can check if a number is odd or even. Cool. You've now just are halfway to creating your own prime number generator. Okay. So now comes so now we know how to do conditionals. Now we know how to do a branch if something is one way or the other. So now let's start doing what computers are really good at, doing things over and over again. So one of the things that you'll be doing a lot of is loops. So there are basically two kinds of loops in Python. We have while loops and we have for loops. Honestly, while loops, you will use them less frequently than you'll use for loops. So the main difference between a while loop is a while loop. While loop is really one step away from an actual condition, where when we did a conditional, we did if this expression evaluates a true, then we do the statement. Okay, a while is exactly like that, except it keeps evaluating that block over and over and over up until whatever is in that condition no longer evaluates true. Okay. So let's do a little example here. So we'll do n equals 1. Okay. And we can do a while, n is less than 5, print is n plus 1. Okay. So we can, okay, yeah, so we did our first loop. Okay. We set our condition there to as long as this statement is true, we keep evaluating this block over and over and over again. And the important thing in this block is to make sure that we have some way of altering that condition. So what if we forgot to do this line, then bad things will happen. Bad things will happen. Okay. Then, oh no, this is going to be really bad. Really, really bad. I'm going to have to stop my session, interrupt my kernel. Oh no. Then I have to restart. Okay. So no, I restarted. Okay. So you know what? That's honestly the worst that could happen. If you make a typo in a loop and you forget a terminal and you forget to terminate the loop, you just restart your kernel. It's no big deal. That's how we learn programming. We learn by experimenting. Okay. So we have the other kind of loop in Python. We have a for loop. Okay. A for loop is really mostly what you'll be using most of. What a for loop is, you iterate or you evaluate that block for every element in a collection. Okay, so if we want to go through, and I haven't really done sequences yet, but this will make sequences clear. So if we have something like a string, remember a string is a sequence of characters. So I can do S equals oops, okay. So we have S. Sequence of characters, okay. What if we want to do something for every element in that sequence? Well, then we can do a for loop like this. For C in S, semicolon, and C. Okay. So what that did there is we have the first keyword here, for. That tells you for every element, okay, C. What C here is, that's just a name that you come up with. It honestly can be anything you like, but that's going to be a name that takes on an element in that collection of things. And then in says the following thing has to be a sequence or a collection, something that is a grouping of things like a string or a list or some other kind of collection, semicolon, and then the indented block of what we actually want to do. Okay. We have another, so string is one collection, and range. So range is something that gives you back a sequence of things. So sequence of numbers. Okay. So you can do for I in range 10, print. Okay. And that prints you all of the elements in that range. Okay. So sequence of things, inclusive. Okay. Pretty straightforward. Okay. So let's do an exercise. Let's calculate the sum of a number, and no, you're not allowed to be Carl Friedrich Gauss and do it the shortcut way. You have to actually sum up all of them. I'm sorry. But yeah, so given two numbers, A and B, let's calculate the sum of all of the odd numbers in B. Okay. So I'll start this here. You can do A equals 1, B equals 4. Then obviously, it's pretty obvious. We have because we're doing the loops thing, we want to do, we could do a for loop, or let's do a for loop here. So we could do for something in something. Okay, so looks like we already got an answer there. So you already got one answer. Let me get a show of hands here of who exactly can do this. I want me to go ahead and show you the answer. And who would like to play? Well, you know what? Let me get a show of hands of who would like to play around with this a little bit. Okay. Okay. So it looks like, oh, should be pretty straightforward. Okay. So we want to do the range thing. So we've and then for x. And then we'll do x 0. Tell me why I start that. And so I wanted all the odd numbers, right? Okay. So I can do, yeah, if. So remember, if x percent to okay. Now, this is wrong, what I did here. Why is this wrong? Yeah, I'm checking if it's even. Ah, so the remainder has to be 1. Okay, yeah. Okay. Yeah, now I get one. Okay, yeah. Why is that? Because range doesn't include the last value. Okay. Inclusive, yeah, it's inclusive. Inclusive, yes, inclusive. Okay. If we want to exclude it, yeah, we need to. Okay. Okay. Inclusive. Add one. Add one for inclusive. Okay, that looks about right. Okay, good. Okay, let's do my sample one. Yep. Okay. My sample data set and my sample output. Okay. So, are we all okay here? Let's see. Resize window. Zoom resizing is a little odd. I'm not quite sure it doesn't resize entirely correctly. Okay. So let's do another little range exercise here. So The default values for range is the stop is 0 and the step size is 1. Okay, but you can also run range over non-number step sizes. It changes slightly in Python, so range, you can do 0, 10. That just gives you a range, but let's see. Okay, so I did a little trick there. Well, not really a trick. I did a type conversion. And remember about an hour ago, I introduced the idea of changing type. Well, range, what range does is it actually gives you back a little funny thing called a range object. And that's sort of a special built-in thing. But if we actually want to view what that looks like as a list, well, we simply change it or convert it to a list. And then we put a list name in front of it, and that changes range the list so we can actually view what's in there. So if we look at these, see how it goes, 1 through 10, and you can see it's exclusive. It doesn't include the last element there. But if we want to go by bigger steps, see the default is 1. Or we can go by bigger steps. So we can do 1 through 10 by steps 2. Okay. Should also be able to do this. Look at that. We can make range go backwards, okay? We can start at a bigger number and go down to a smaller number if our steps are negative. If we leave that out, so because I left out the step size, well, obviously it's starting at 1, going to 10, because the default step is 1, it's just going to be an empty set there. I have to do -1. -1 actually tells it to take each step in negative direction. Okay? So, but so the next level of sophistication here is, let's say we're in a while loop and we want to terminate, we want to break out of that loop for some reason. Well, that's why we use the break. Oops. That's why I use the break keyword. Okay, so the syntax there is while, condition, expressions, and then we can do if something, then we can break. Okay. So a good example here is, let's go ahead and type this expression here. Okay. So my sum is 0. So while I'm typing this, why don't I get some guesses as to what do you think will happen here? Oh, I got a typo here. I got a typo here. Oops. Yeah, I got a typo. I need to fix this. Okay. What did I mean to do? I meant to do one. Ah, because that's a typo. Yeah, okay. Good answer, yeah. So what's going to happen here is because we're going to start off with my sum equals 0 for I in range 5, 11, 2. Okay. So I is going to take on 5, okay? So my sum will be set to 5, okay? And we'll break, but because we're breaking, we're going to completely bail out of whatever we're doing here and not execute this. Yeah, okay, yeah. So we go there, and then we're going through the values, and then the very first value we encounter, boom, it's 5. Okay, we set 5 to my sum. My sum, yeah, sure, it's 5. We're breaking. So any statement after a break will never be executed. We're just going to completely break out of that loop. Okay, good answers. Okay, so a little summary of loops. So the big thing is for loops. So for loops, we are always looping over a collection of things. So it's for item in stuff. All pretty much everything you'll be doing in Tellurium will be for loops. Probably 90% of the stuff that you'll be doing in CompuCell is for loops, where you'll be looping over cells. You'll be looping over neighbors. You'll be looping over collections of things. You will probably encounter situations where you'll need a while loop, but certainly much less frequently than what you'll be using for loops for. Okay. So both for loops and while loops, you can exit out of them early using a break statement. In a for loop, you know the exact item that is in the collection that you're looking at. Okay, yeah. So no, a break statement means only the current loop that you're presently in terminates. Your program continues on executing. So if I had, even if I had something like this, so if I had for n in for I, okay. um, so a little example here. Okay, so what we did was we looped over all the ends in an outer range, and we had an inner loop where we looped over all of the i's in a range, and we added all those together. And then, of course, those are 900. But let's put a break statement here. If I hold on, yeah. But let me change the order of this. Yeah, okay. So we looped over those, but then it only executed the outer one. Yeah, because it breaks out of the inner loop. So a break only exits the current loop that it's in. But you can have many, many nested levels of loops, and the break only exits out of the current loop that that break is in, but everything outside of that continues executing. Okay, good question. Um, so in general, we can replace a for loop with a while loop. The syntax is a little complicated, but you can do it. You generally, while loops, they continue, while loops continue going on up until that end condition is stopped. So if you're doing something like, I'll say monitoring some outside input or monitoring some user events, you probably would want to use a loop there, like continue while processing continue doing. So, okay, that's basically on loops. So, do we have any questions on basic loops and conditionals?